we acknowledge that the land on which we are gathered here today is the home and traditional land belonging to the Tongva Nation. Today we come with respect and gratitude for the Tongva people who still consider themselves the caretakers of this land. It is through their examples that we are reminded of our greater responsibility to take care of Mother Earth and to take care of each other. Welcome to Wild California, a science and naturalism educational webinar being presented by the Dominguez Rancho Adobe Museum and the California Naturalist Project. I am Lauren Croman from the Santa Ana College, and I am pleased to be with you today. We are hosted today by the museum itself, and we thank them for helping us out with this webinar and letting us use their grounds. They are closed to the public at the moment, but as you can see, their grounds and their program go on, and they're doing beautifully in pursuing their mission statement for public education and community cultural enrichment. So thank you, folks. This webinar is to help the public understand Wild California as it exists outside our everyday, day-to-day lives that frequently get swallowed by the city and more necessary moment-to-moment concerns, especially right now. Today we'll be starting from the ground up, literally, from how California is shaped, what makes our climate possible, and how that affects what our wild California looks like outside of our cities. Toward the end of our webinar series, we'll transition from what lives out in our natural Californian setting and our habitats into how we as humans interact with it and have been interacting with it historically. So we're really pleased to have you join us today. We'll start today with our Californian climate. What makes California so unique versus the rest of the United States and even the rest of the world? If you've lived in California for any length of time, you may have a feeling that our region of the country of North America is unique. It's not just culturally that we're special. We're also unique and special from a geographical and biological point of view. As a field biologist conducting research in the field about animal behavior and native plants, I have a very deep feeling about this, but it's not enough for me to tell you, look, we're really lucky to be studying and experiencing wild California. I want you to know why. California doesn't just feel special to those of us who live here. It is a unique region, not just for North America, but also in the entire biosphere, the whole planet, in many ways. Not only do we, especially here in Southern California, have a Mediterranean climate, a climate type that is found only in a very narrow band around the perimeter of the planet, and only in a very few specific places. We also have a topography. The physical shape of California as an entire state is so different from the rest of the country and most places in the rest of the world. There are literally very, very few places that can say they have as much biodiversity and as much variety for life as California does. There are so few, in fact, we know their exact number. California is one of 25 of what biologists and ecologists call hotspots, biodiversity hotspots on the entire planet. These are areas of the planet, not surprisingly, including a lot of areas in the tropics that are known for a huge proliferation of plant and animal life, that have the perfect variety of climate conditions and types of habitat to allow a huge boom of biodiversity, different species, plants and animals alike, to live all within one basic region, even if that region is as large as our state. When I say that we have a Mediterranean climate, let me back up here for a moment and explain exactly what that means. This is a technical term from ecology, and it describes the specific set of conditions that if you live in Southern California, you're familiar with in a day-to-day and a year-round seasonal basis. A Mediterranean climate is why our weather here and the way we experience seasons is different compared to the rest of the country. Our summers are hot and long and getting hotter and longer all the time. We don't really have properly cold winters. Michigan would laugh at us. 60 degrees? Haha, yeah, sure. They get 2-digit degrees during the winter. There's just a negative sign in front of it. Here, our spring is what everyone else considers to be winter. If you consider that spring is when most places tend to get a lot of their rain that starts up new plant growth for the following year. Think about it. In your own experience of living here, being anywhere in California, when do we normally get our rain? Well, especially if you live down here in Southern California, you're probably thinking of January, February, areas that in the rest of the continent are pretty much the heart and soul of winter. January can be some of the coldest temperatures in the rest of the country, and sure, that's true here. We're just functioning at a different metric. We don't get proper deep freezes through most of California, but it is when we get most of our precipitation. At the time of year where everyone else is getting snow, hail, even sleet, a form of frozen rain, we're getting regular rain. And all right, I'm biased. If we're lucky, we get an El Nino year and properly get a lot of rain. Maybe too much rain, bear with me. I'm biased. What that means is our climate doesn't get a lot of the cold extremes that can be associated with that time of year for the rest of North America. Don't get me wrong, we get extreme temperatures, you know what they're like, but they're in the summer. We're defined climatically, our weather, by hot, long, dry summers and relatively, comparatively short, cool but not cold, wet, rainy winters. What this means is that whole suites of types of plants that normally might die during a really harsh winter cold snap, a freeze, here can proliferate. It also means that there's a whole host of migratory pathways for insects, like the monarch butterfly, bats, and birds that come through California twice a year, flying overhead and through our cities and across our landscape to get to wintering grounds and then back again during their mating season to their mating grounds. This relatively kind climate means that all of this life, even the visitors, are possible here in California in a way that literally is not physically or climatically possible in most other places in the entire world. But if you step outside of day-to-day worries, take a trail, look at the mountains. Even when it's dry and brown, don't let it fool you. Our plants are masters at drought control and coming back after fire. So even when our local valleys and mountains don't necessarily look their best, they are still profoundly well developed and evolved for this climate. And they have been living in this climate for so long, under these rare conditions, this incredible opportunity that we also have available to us to enjoy, that our local biodiversity, the wealth of species, of different types of life that can live here in California, has bloomed and grown over evolutionary time in ways that you will be hard-pressed to find elsewhere in the entire world. If you have the opportunity to get outside, take some time for yourself. Time spent on yourself matters. And time spent outside, we know from the study of psychology and how our brains work, from neurology, we know that time spent outside in wild places, at least green places, is good for us, even healthy for us. When you can do it here in California, a place unlike so many others in the world, you truly have an incredible gift, a privilege. And part of what we're going to talk about here in this webinar is how to know what you're seeing. I want you to be able to ideally get out into your local canyons and trail sides, at least by the end of this webinar series, and have a better, more confident knowledge of what it is that you're seeing, what plants are around you, so that you can better understand where you are and how it lives. These are the fruit of the pepper tree. They'll start growing green, change color as you can see, and as the season progresses, this pink skin will dry, become very papery, and eventually kind of flake off the seed inside. It's a relative of what you and I know as our ground table pepper, and while the kernel is not exactly identical, It's pretty darn close. You can tell they're related to what you and I use as a spice and a condiment. But this is from our native representative of the group, from the California native pepper tree, which you can see doing extremely well here on the museum grounds. When I say that California's climate makes a wide variety of life possible, though, I'm talking about a lot more than just what evolved here. As human beings came into the area gradually over time, and especially in the last 100 years or so, when we've had a massive influx of people discovering, hey, California is beautiful, there's resources here, come live here, we've brought in a lot of ornamental species with us, plants that we enjoy for their beauty or their fruit. Usually, in the case of ornamental species, their beauty. Because of our climate here, without extreme cold that other areas of the country get, plants from a huge variety of other countries survive here very well. There's actually some really great examples here on the museum. Let me show you. Practically right next door to their California pepper here on the museum grounds is this beautiful example of a tropical tree. Meet the silk floss tree. In fact, as you can see, up in the branches of the tree right now is what results from the ripe fruit of the tree. Eventually, the seed pod bursts open, and the seeds themselves are encased in a very silky plant fiber, the namesake of the tree. In its native range in South America, that floss will be used by various birds and even some primates as bedding material, nesting material. But here it's doing perfectly well in a garden far, far from home, in a climate with not nearly the same amount of water, but because it's here in a garden, being cared for, the rest of the climate is close enough to what it can tolerate that this plant is doing extremely well. Now, we've caught it a little bit late in the season, and while it still has plenty of flowers up on its branches, as you can see, a lot of them have fallen afterwards, which gives me a beautiful example to show you what they look like up close. Now, you can use my hands as a size reference. See how large and how vivid the colors are of this flower. It's a beautiful, almost magenta pink, with a center stamen that kind of reminds you of a hibiscus, doesn't it? Same shape, pretty much the same size. But what I love is, look at the spots in the center. Almost like a Dalmatian at high speed. Now, a lot of flowers like this, we'll talk about this again when we talk about plants properly. A lot of petals like this have patterns and markings that we can't even see with our eyes. They're typically in the ultraviolet or the infrared spectrum of light. And we aren't evolved to see them because we don't have the right relationship with these plants. But pollinators, like insects and many birds, and believe it or not, even some spiders and bats, depending on the species, do have the correct vision to see these markings, and they guide pollinators in towards the center of the flower, where when the flower is on the tree and doing well, and not gradually coming apart in my hands, there's a source of food down at the center, usually nectar or additional pollen of some kind. Basically, they're like giant, for insects specifically, eat here, eat at Joe's, landing pad this way, come get the food, signs to encourage them to come to the flower, here we go, and even come to the correct place on the flower. And even though this is a tropical species, that same relationship persists through any flowering plant you might see. Continuing in our brief tour of examples of variety that's possible here in California, at least this tree also lives in a natural Mediterranean climate, just not here, not naturally. What you're seeing is an olive tree, and a really well-grown one. This is a beautiful example. So olive trees grow very slowly, very slowly. Their wood can come in very dense and hard. It makes for beautiful woodworking if you're patient. The grain of the wood inside has got these beautiful waves of dark to light colors. It's very distinctive. If you ever get to see something made of olive wood, it's not going to look like anything else It has these beautiful honey colors into it. It's really very beautiful. It's been valued both for the olives, for eating, for making olive oil, as well as for the wood itself for a very long time. If you enjoy olives, olive oil, or if like me, they made you read the Iliad and the Odyssey in high school and again in college, you might be familiar with this. The base of Odysseus's bed is actually built from an olive stump. The stump and the roots can be so hard to take out that even historically, instead of trying to tackle that job, they just cut it and built around it. The wood can be that hard. It is, however, from a Mediterranean climate, like our native Californian pepper that we were looking at earlier. Greece, unsurprisingly, around the Mediterranean Sea, has a very similar climate. And if you ever see photos of the Greek countryside, you might think you were looking at the San Gabriel Mountains. They look incredibly similar. The plants look incredibly similar. It kind of takes a moment really looking at them to realize, wait, I don't actually know that species. Because they look so similar and they have so many of the same adaptations. Just like here, they have long, hot, dry summers, cool, relatively short, wet, rainy winters, which means olives and other plants that are actually from a Mediterranean climate grow here exactly as well as they do at home. Come here, let me show you how to recognize this plant up close. Now we'll talk about some of these adaptations about our own native Californian plants when we talk about plants as a whole webinar subject, but here's some things to look at to begin with. See these saplings? See how pale the stems are and the underside of the leaves? This is actually an adaptation we see really often in plants that live in an area just like Southern California. As you can see, these leaves keep that coloration for their entire lives. So even though this is a sapling, these leaves are going to keep that dark versus light color well into adulthood. You can also see the distinctive way the bark grows. Now, again, we'll talk about this when we do plants by themselves, but sometimes, especially with trees, the way the bark grows on a tree can be a really useful way to help you identify exactly what you're looking at. See how narrow the individual pieces of bark are and how they flow, breaking a little bit, forming edges, and flow down the tree almost like a water pattern. Like you were looking at patterns and currents in a stream or along the ocean. It's a really good way. That and the silvery pale gray color of the olive tree define it really well. And you'll probably see olive quite a bit when you're around town because it's also from a Mediterranean climate and it does so well out here. It's actually pretty popular for a lot of municipal plantings and in folks' gardens. It's doing really well out here. All right, so we have 3 different things going on here, and what do I geek out with you about first? Well, let's maybe go in order of size, shall we? So, speaking of diversity and variety, Southern California is known for one particular type of plant, aren't we? Palm trees. Do you know that's not even actually a tree? Its closest relative are grasses. The reason I say, despite its size, it's not actually a tree is because physiologically, botanically, the structures inside a palm tree that it uses to get nutrients and water up from its roots in the soil, they're not even true roots, not really, all the way up this incredible trunk to the fronds at the top, they're not even the same types of tissues as the California pepper or the silk floss tree or the olive. Whereas they have got a couple different types of tissues they use, and they're specialized to move just water and nutrients, or nutrients and maybe some sugars around. A center cut through a palm tree looks much more like the tissues of bamboo, or even of lawn grass by comparison. So this palm tree that Los Angeles in particular and the Southland at large is known for iconically throughout the history of movies and TV and postcards and photography. It's not even actually a tree, and you bet it's not from around here. These are primarily from the Bahamas. but also from around the tropical belt around the equator. They do well here because Lord knows they can handle the heat. They can deal and typically prefer more water than they'll get here at any particular year, but it's that heat tolerance that makes it possible for them to, well, become one of the most photographed icons here in Southern California. This particular palm tree here at the museum is in an unusual relationship with another plant. This large, well-bushed out, well-grown out vine that's coming so far down the trunk of this palm tree is a variety of honeysuckle. Now, in other areas of the country, primarily the south and southeastern region, this is a terrible invasive plant that will take over an area and drive out native species. Here, we get not too hot, but too dry in order for this vine to start really become damaging. If we had weather and humidity more like perhaps Southern Carolina or maybe Mississippi, then we would really have a problem on our hands. But the extreme temperatures we get here during the summer really help keep it in check. You can recognize this vine, especially when it is blooming late in the season, as cooperatively and conveniently as this one is, by its namesake flowers. These delicate little narrow trumpets in shades of white or pale gold have a well of nectar down at the base of the flower. And this is a major attractant to some hummingbirds. But what we're seeing today is a whole bunch of butterflies, which is the last point I'd really like to share with you. Now we have 3 different major species of butterflies visiting this plant that we've seen in the last couple of minutes. We have some cabbage whites, some skippers, but look, this one. The one we've really been geeking out about is the Gulf fritillary. It's a little bit smaller than a monarch, about the size of a viceroy if you know your butterflies for any reason. But it has a very, very similar shade of orange. So if you see a butterfly about yay big, that's maybe 2.5, almost 3 inches across, with this beautiful sort of sunset orange color to it, but without the really distinctive black kind of window frame pattern that you'll see on a monarch's wings, and also without the big white windows that you'll see on a monarch. You might see spots on the underneath. If you see that orange, about that size, you may be looking at one of our California natives, the Gulf fritillary. And we have been watching the last couple of minutes, a whole bunch of them come visit these flowers that are still available. It's actually a wonderful opportunity to talk about some of the beneficial roles of ornamental species here like this honeysuckle. Would it be good if this plant made it loose and uncontrolled into the native habitat? Well, no, that would be damaging. And at least we're not, again, in an area where it's terribly invasive. But that doesn't mean that it doesn't have use and value from an ecological standpoint. It's planted here for its beauty in this garden, but plainly, native wildlife don't mind using it as a food source. It's one of the reasons why ecologists lately have been really encouraging folks to plant for our climate. Plant for drought, but hey, maybe think about planting for pollinators. We have a lot of pollinators that have been having a really hard time lately. If you're not familiar with the problems our native bee species have been having, boy, we will talk about that when we talk about wildlife. Hive collapse is a thing, and your native bees, actually all of our bees, even if bees aren't your favorite insect, our bees really need a lot of help. So planting for pollinators, whether they're birds or butterflies or bees, is always a worthwhile thing to consider when you have the option. So we've come here to the desert garden hunting more butterflies, and we have not been disappointed. We just spotted a tiger butterfly go by. There's a western swallowtail up on the top of yet another silk-moss tree. We've got sulfur butterflies coming by. We've got little rusty-colored skippers. This is a wonderful example of what can be done when you have the right region to work with. When I say region, what I'm referring to is a bioregion. Now, I was talking earlier about how unique California is, and plainly I'm biased, but you know what, sit down for a second. This is going to be a soapbox. I have opinions about this. We're going to enjoy this for a moment. So, when we study ecology, there's a technical term that we use to describe the set of conditions, usually climate, but also soil aspect, things like this, that make it possible for a set of related habitats to develop in the same climate. Things like our closely related chaparral and coastal sage-grouse, or up north, various subtypes of boreal forest, things like that. Most areas of the country, and when I say area, I mean like most whole states, have maybe 2 or 3 regions, perhaps 4 when you're lucky and you get something really unusual. This applies even to areas like Alaska and Hawaii that are world famous for their breathtaking landscapes, for their wildlife and their wild plants. Even they are mostly the same type of bioregion. Gonna take a moment to acknowledge the bird in the room. Up at the top of that Monterey pine. I know it's got the sun behind it, which might make that a little bit difficult. We have a raven who's joined us. You can tell it by that sort of low, kind of throaty, almost like a rolling R quality to its call. They're also a lot bigger than crows. They are bigger than that. Like, picture how big you think a crow is. Bigger than that. Now bigger than that. There's a reason Edgar Allan Poe had a whole poem about them. They are large birds. It's solitary, and it's calling perhaps to attract others. Perhaps because it sees us and it's like, you are disturbing me. How dare you? It's croaking a little bit at us. This is fine. It's native to the area. Bioregions. So most areas, even Florida with the Everglades, even areas like Yellowstone National Park, which, I mean, for me, for an ecologist, for someone who works in the field, is like one of the holy grail places you want to go visit. So there's the Everglades. Even these areas have maybe a couple different types of bioregion. Here in California, we have 10. 10! Okay, think about it. You know, like the joke, the old adage that, well, you know, in Southern California, you can go skiing in the morning and surfing in the afternoon. It's funny, sure, but it's true, isn't it? Provided you've got the right time of year. California is a landscape of extremes. While we may get laughed at by properly cold areas like Minnesota in the winter, we get them back come summertime. Triple degree digits, that cold? Sure, come here in August. 124 in the shade. Try that one on. We get them back for it. But we also have a physical landscape of extremes. Some of the highest points and the lowest points in the entire country are here in California, between the Sierra Nevada mountains and the depths of Death Valley. This means that also the same length of California, coming clear from Mexico up to Oregon, means that between physical topography, and we'll get into that, but also just how long California is, gives us one region with a wide variety of different microclimates. Now, microclimate is exactly what it sounds like. It is the unique, localized set of conditions you might see in a much smaller area. Where we might talk about a whole climate, like a Mediterranean climate for all of California, microclimate might be just your neighborhood, just one hillside. Literally, not just the whole hill, just one side of the hill. Because differences that approach each side are gonna make temperatures a little bit different. And those temperatures are gonna make how water hangs around a little bit different. In fact, bear with me on this. Close your eyes for a second. I know, it's a webinar, it doesn't make any difference, but bear with me. I'm a geek, go with it. Close your eyes for a second. And think about it. Do you have in your home, or maybe you're the place where you work, a part of the building that during the summer is the one part of the building you don't want to go anywhere near? It is always too hot. It doesn't matter what you try and do to cool that one room or hallway down. It's always too hot. But come wintertime, okay, nice, that's comfortable. Or there's always some part of your house or your building that's cooler than the rest of the building. This is a personal example of microclimate. We're here in the northern hemisphere. We're north of the equator. And that means that even though right now it's just past noon, the sun stays at least a little bit to our south, even at noon when it ought to be pretty much right overhead, right? But it will stay always just a little bit to our south of where we perceive ourselves of being. Like I'm standing here and the sun certainly is not directly overhead, it's up and over, not just straight up. This is because of the hemisphere we're all standing in at this point. Facing south, even on a really localized level that can cause a microclimate, will cause changes that you're familiar with. The same way that one room or one area of your building that's always hot no matter what you do is that way, is the same reason why certain areas of our habitat look the way they do. That area that's always too warm, no matter what you set the thermostat to or put a fan in there, no matter what you do, is likely, almost guaranteed, going to be that warm because it is a south-facing area of the building. Here in the northern hemisphere, that means that even during the morning, when the sun might otherwise be on the opposite side of the building, that one area is going to get more sun than anywhere else in the building throughout the course of the day. You let that build up day after day after day over time, yeah, of course, that's going to be the warmest room in the house. On the flip side, on the other side of the building, where you get something north-facing, that means it's always going to be at least a little bit more in the shade. It's going to keep the temperature down at least a little bit. If you're like me and you like a nice cool room, check out the north side of your house. Maybe you'll be more successful and more comfortable. But if we take this same concept out of our homes and bring them out into a habitat, these are the kinds of differences we start seeing. In a southern-facing area, even if it's just one side of a hill, plants are going to be smaller, even if they're the same species. The soil is going to be drier. Because it gets more sunlight over the course of the day, it dries out faster because it's also receiving more heat. So like morning dew, bit of drizzle, actual rain, they don't get as much opportunity to sink down into the soil. They evaporate out much more quickly. So for instance, our southern-facing mountainsides of the San Gabriel Mountains, one of the reasons they look predominantly, brown, is because they receive less precipitation, less water in some form they can actually hold on to, and it evaporates more quickly. And this results in fewer plants, smaller plants, generally hotter, drier landscape. But it also means that the plants that you will find there and the wildlife that will live there because of those plants are going to be truly well adapted to heat and lack of water, aridity. Let's have a look at what it would look like if we flip this around and go to the other extreme on a north-facing slope. So you come over here with a beautiful adobe in the background, standing in the roots of this gorgeous river tree to show you a hyperbole, an extreme comparison of what a north-facing slope can be like. The same way that a south-facing slope gets hotter, drier, doesn't get to hold on to its water as much, and that changes which plants can grow there and how they will grow there. A north-facing slope has the same effects, all of them, just in the opposite direction. A north-facing slope stays a little bit cooler, gets a little bit less sun, and that means that some plants may not do as well. Plants that need a little bit or can tolerate a little bit more shade deal well with north-facing slope conditions here in California. The major benefit of that for those plants is being able to get to hold on to a little bit more water. Whether it's morning dew, coastal fog, marine layer, or rain, those plants get a prolonged opportunity to actually soak up some water through their roots because it doesn't evaporate quite as quickly. When we talk about plant and animal adaptations in a later episode, you'll hear me say this a lot, but it's true all the time. A lot of evolution and adaptations that make some species really well adapted to surviving certain conditions are all about how those adaptations add up and create an ability to survive when you add them all together. It's all about a little bit at a time. Every little bit helps and makes a difference. There is no one adaptation that all by itself makes a plant or an animal really rock out at surviving here in our local climate. But each one of them that does well, is native here and adapted to be here, has a whole suite of adaptations, each one of which make it a little bit better, a little bit better. Being able to get that water through their roots as quickly as possible, whatever is available, and being able to handle heat, dry weather, or conversely, a little bit cooler temperature, even when they're otherwise adapted for heat, is just one more way a lot of our wild California is well adapted to being. Now we'll go ahead and switch gears. We've been closing in and looking closer and closer at the small changes that things like aspect and direction can make. Now I want us to zoom out to the entire state of California and how California is built, our topography, how we're mapped out, and what kind of geographical and geological formations we have here. And let's talk about the great big picture and how that makes our climate and our variety possible. Here in the shadow of these trees, let's talk about a different type of shadow and what casts it. Now, if you live here in Southern California, you're going to be familiar, no doubt, with a lot of our different towns here inside, say, LA County and other counties around the area. And you may notice certain areas get a lot more rain than others, usually on one side of our mountains versus another. Well, here in Southern California, we have some very iconic and also very unusual mountain ranges. You see, most mountains in North America run in the same direction, from north to south. In fact, we have two really well-established mountain ranges that do that, running down most of the length of our state, the coastal ranges and the Sierra Nevadas. Between the two of them, they form a trough. And with a different type of mountain range at either end, this forms a vast bowl, the Central Valley. That local Californian bread bowl that lets us farm so magnificently that we feed most of the rest of the country on produce that we grow here and harvest here in Southern California. That farmland is possible because of these mountain ranges and how protected the Great Central Valley is, using rain and collecting rain from local mountains. The way that works up there is this. Let's talk a little meteorology, basic stuff, but let's also talk water. When water vapor evaporates from the ocean, water vapor rises with warm air, and eventually, when it gets up to altitude, it starts to cool down. When water vapor cools down, it condenses and forms liquid water again, water droplets, tiny, almost microscopic sometimes. This, at large scale, forms clouds. Clouds are still light enough because they're mostly water vapor that they can be carried through our atmosphere by prevailing winds at altitude. The direction that clouds are carried by those winds form large patterns throughout the atmosphere of our planet. Great invisible swirling currents, as though you've taken a spoon into your cup of coffee or tea and started to swirl it round and round as you stir in the milk. Same idea with how we get our weather in one area of a country versus another. These air currents carry clouds, and with them that potential for rain or snow from ocean, eventually over land. As clouds carry over land, especially if they start running up against mountains. They start to cool down further. And the more that water vapor cools, the more it condenses. And over land, this may fall as precipitation of some kind. Now, precipitation is a technical term that really refers to any way water can fall to the ground. It depends on your region and your temperature. Cold, relatively dry, have some snow. Nice, fine powder that gives us great skiing, snowboarding, what have you. A little bit wetter, maybe you get sleet. Water that falls as rain and freezes on the way down. Not as happy, slightly miserable weather. Elsewhere, you may get hail or rain. Here locally, especially in Southern California, most of the precipitation we receive falls as rain because of how relatively warm our temperatures are here all year round. Again, we get cool, short winters, but this isn't like the howling winter winds of Illinois. We've got nothing on that. When that rain starts to fall, clouds gradually lose some of their weight. Makes sense, right? They're losing all of this heavier water vapor, and what's left of the cloud gradually lightens up. And as it physically lightens, it also gains more elevation. It can float higher. This is where this becomes important for the Great Central Valley and also for your day-to-day experience around the area of California you call home. Clouds are frequently at high enough elevation they could just float over a lower mountain range, like our coastal ranges. When they come against a mountain range that really has some teeth to it, like the Sierra Nevadas, the mountains are too tall for the clouds to just pass overhead on prevailing wind currents. And they start physically backing up against the elevation and the wall of those mountains. As they back up, they cool off some more, dropping more water until they're finally light enough to pass over the mountain range, and in the case of the Sierra Nevadas, to the desert on the other side. That water flows down those west-facing slopes of the Sierra Nevadas into the Great Central Valley, helping to irrigate it, get it water, feed that soil. As the rain flows down into streams and rivers, it picks up nutrients from soil and helps fertilize the Great Central Valley as well. This one weather phenomenon in the right climate, in the right area, has helped create an economy and an agricultural booming business here in California that helps us define what your table is in the evenings for the rest of the country, and especially here in California. We're famous for our produce. But that's to our north, at least here locally at the museum. So let's talk about stuff that we know day to day. I did say most mountain ranges run from north to south across our landscape. Not all of them. There's a second type of mountain range. They're normally smaller, shorter, not necessarily shorter in elevation. And there aren't nearly as many examples of this as there are of the normal direction. But our local San Gabriel and Santa Monica mountains include these, especially the Sierra Madres. These are transverse mountain ranges. Trans meaning across, like to transport something, to carry it across a distance. Transverse mountain ranges run along an opposite axis, perpendicular to the normal mountain direction. So instead of running north to south, they run, in our case, west to east. Unusual. But around here, they help really establish a lot of what our local habitats and climate are like. Our San Gabriel's and Sierra Madre Mountains are transverse ranges, and that means that most of Los Angeles County and even parts of San Bernardino and Orange County back up against these mountains and their foothills. In the same way that when clouds back up against the Sierra Nevadas over the Great Central Valley and drop their rain there, clouds that come in off our immediate coast come up against or across against these mountains, get stuck against their height, cool off, and start to dry out some by dropping that rain. In practice, It's the reason why on one side of the San Gabriel Mountains and the Sierra Madres, you'll have Burbank, La Cañada, Flint Ridge, Pasadena, Monrovia, Altadena, heading further east. But on the other side, you'll have Santa Clarita and Victorville. Just picture in your head for a moment, if you've ever driven out and visited any of these cities, what their mountains and their local area look like as you pass through along the freeway, especially during spring. Get them at their best time. Areas like Monrovia and Pasadena are frequently greener. Their mountains are bushier. They've got a greater wealth of growing life. It's because they're receiving this extra rain. On the flip side, areas like Santa Clarita and Victorville tend to be much drier. Fewer plants on their mountains, and those plants are tough and hardy as nails. A lot of their geographical backdrop tends to be in tones of tan and dust and brown and dust-laden green leaves surviving the extra heat and the lack of water. It's also one of the reasons why you can get the LA Basin on one side and the Mojave Desert on the other. The LA Basin are local habitats down here like chaparral and coastal sage scrub. In a normal year, whatever passes for normal now, normally receives about 13 inches of rain on average per year. On the other side of the mountains, the Mojave Desert, which you'll have seen if you head out towards Baker, or if you've ever made the drive from anywhere around here out to, say, Las Vegas, you'll pass clear through areas of the Mojave Desert National Park. Those areas historically normally receive about 10 inches of rain a year. Think about the difference this makes. Just close your eyes and think about it for a moment. Or if you want, go Google a photo of the Mojave Desert. It's a webinar. I won't know. I won't judge you. Take a look at that comparison, either on the internet or in your own memories, between our local mountains and what they look like as they face the city and the middle of the Mojave Desert. This is the result of a phenomenon that has a very specific name. It is a rain shadow. The rain shadow is that vast area of dry habitat that results from those clouds backing up against the mountains, not being able to pass straight overhead, but dropping their rain until they have lost enough weight to be able to rise over the mountains afterward. This happens because normally when those clouds have lost enough weight and they've lightened up and actually made it all the way over the mountain range, they don't have enough water vapor left in them to really dump a lot of rain or other precipitation on the desert on the other side. So one side gets the lion's share of water from those clouds, and the other side makes do with a pittance. Now, here in Southern California, most of our climate tends to be dry enough that the amount of rain, the difference in the amount of rain between the lusher, greener side of our mountains and the rain shadow on the other side is historically about 3 inches of rain a year. 3 inches of rain a year. That is not a lot. But our local habitats here on the rainward side of the shadow are so deeply and intensely well adapted to living here, they can make a lush growth out of 13 inches of rain. On the other side, look, I'm biased. I'm your friendly local bio geek. I know a lot of folks aren't necessarily as enchanted with the desert as me and some of my colleagues, but the plants that make it, that survive well on that 3 inches difference, on that 10 inches of rain a year versus 13, the adaptations we see there, it's almost like they're living on another planet. It's incredible. California is a landscape of extremes. Extreme heat, extreme elevation and depth, but also just the habitats that this creates. Everything from alpine forests all the way to our local coastline and everything you can find there, tide pools, tiny little native sub-habitats that you'll find here and nowhere else. In fact, check this one out for size. There are between, depending on how well they're doing and how we're counting, between 30 and 50,000 different species of native plants to here in California, and a lot of them are endemic. Now, this is a technical term from conservation biology. Endemic means that a species isn't just native to an area, it's found there and only there in all the world. Remember how I was talking about biodiversity hotspots? California is one of them, one of 25 in all the world. Areas like our home are so few and far between, we can literally number how many of them there are in the entire planet. We have such a huge wealth of endemic species found here and only here. This means that if they're lost locally, they can be lost globally. A lot of folks don't know that of all of the species on the endangered species list that protect wildlife and plants here in the United States, there's actually a very, very large number of them that are here in California. We were talking earlier about the great privilege and the gift of being here in California. And this is one of the reasons why. Now, if you already knew this, welcome to the choir. Sorry to preach to you. But if not, or if you know someone who maybe doesn't understand, why do certain geeks get so passionate about preserving and protecting our wild places? This is why. We are one of 25 biodiversity hotspots for the entire planet. You are here, you are living in it and in its backyard. If we can't protect the species we have and we lose them, the whole world will lose them and they can be lost forever. We have an incredible jewel box full of species that are here and nowhere else in the entire world. Now, there are generations and generations of people who are dedicated stewards, whether they are climatologists, biologists, field biologists, whether they are members of Native American tribes whose ancestors and whose current living culture involves stewardship and it goes back for hundreds of years. We understand what we have here. My hope is that through today, and hopefully if you'll join us, further episodes of our Wild California webinar, that maybe I can share with you some of what is fantastic. Please, let me share with you the things that I love about being out here. But it also may help you understand, or perhaps more likely, explain to others who just don't know what they've got here, what's going on when you get out into our wild places.